Hey everyone, welcome back to this channel. Today onwards, we will study about object-oriented programming, that is also known as OOPS. Now first, let me read out the definition. OOPS is centered around the concept of objects and classes. You write classes that represent real-world things, and you create objects based on these classes. In simple language, everything around us are objects, which belongs to a particular class. So class is the blueprint for creating objects. An object is the instance of a class. Let me give you some example. Organization. If an organization is a class and the employees are objects, they belong to the organization. They are equipped with general behavior that an organization have. Okay, let's think vehicle. Vehicle is a class. Truck, bike, bicycle, these are objects because these holds some general features of the vehicle. Suppose a vehicle must have some engine, wheels. So the objects like the truck or the bike or the car, they must have all these features of vehicle. Now you can give them whatever unique traits you desire. So you understand the concept of classes and objects. Classes are blueprint and object is the instance of a class. So objects are whatever all around us, everything. I have a laptop, that is an object. That may belong to any class, like it may belong to a machine. Okay, so objects are also known as the instances of a class. Now let me create an object. Okay, I will create a class, dog class. So first I have to write the keyword class, name of the class, any name you want to provide, colon. Then you can give any doxstring. Doxstring, you remember we studied during function that explains about what we are going to write about dog class. This is not mandatory. It is a good practice. Now inside the class, we will have attributes and functions. Function starts with a def keyword. Now I have to give init. I will explain this. Inside this, we will pass some parameter. Self, name, age. Okay. Now self dot name equals to name, self dot age equals to age, def sit self. Don't worry about self. Now print self dot name is now sitting. Okay, I will write one more function, def act self print formatted string self dot name is now acting. Okay, so this is the syntax of a class. Starts with a class function, name, semicolon, docstring, and inside this you can write functions. Now let me explain you what I have written one by one. First one is init, double underscore, init, double underscore. This is a special method that Python runs automatically whenever we create a new instance based on the dog class. Whenever we will create an object, this function will run automatically. Okay, but all other functions are not like that. They will only execute when they are called, just like the concept of functions. But this is a function that will automatically execute whenever the object is called. That is why double underscore is given so that you can differentiate between this special method with other methods. Now see, init method has three parameters: self, name, age. Self parameter is required in the method definition and it should be at the first position before the other parameters. When Python calls this method, this init method, to create an instance of dog, to create an object of dog, the method call will automatically pass the self argument. So whenever we create an instance, this function will be automatically executed. Now let me create an object first. My dog equals to dog, comma 6. Tom is the name, 6 is the age. So Tom name will be passed to this name parameter, 6 will be passed to the age parameter. Okay. So whenever I execute this line, automatically an object will be created. The name of the object is my dog. It will automatically call the dog function and execute this method where self is a reference to the instance, name is Tom, age is 6. And now this individual instance, my dog, can access this attribute. Attributes is like name, age for a dog. Now these are the functions, other functions. You can write as many functions as you want depending on your requirements. Now there are two terms. One is attribute, another one is functions. What is the difference? Like suppose you have a car. The color of the car is an attribute. But when it is in work, like driving the car, that is known as function. The name of the dog is an attribute. Age of the dog is an attribute. Color of the dog is an attribute. But when the dog is doing some work, like it is sitting or it is playing, eating, these are known as functions. So that is the difference between attribute and functions. Okay, but these functions, when they are written inside a class, they are known as methods. So there is no specific difference between method and function. The concept is same, but when it is written inside a class, it is known as a method. So now onwards, we will talk. These are attributes. These are methods. Okay. So dog is a class. My dog is an object. This is an special method, also known as constructor. This must contain the self attribute because self is a reference to the object, to the instance, and other parameters depending on your requirements. These are known as attributes. Whenever I call this, whenever I execute this statement, automatically my dog will be passed as self, and for my dog dot name, the name will be given, that is Tom. For my dog age, age will be passed, that is 6. So if I try to print, like if now I want to print my dog dot name, then the name of the dog will be printed. Oh, I'm so sorry. I have not executed this. Okay. If I want to print age, now let me give you another example. Here, see, this is a class person. I have not written anything inside it. Now, what is person one? This is an object of the person class, an instance of the person class. Now, it consists of two things. One is attribute, person dot name, person one dot name, person one dot age. So these are attribute. Now, when we define any behavior, like what the person is doing, performing any function, that is known as method. Clear? See here, the init constructor is defined. Self, name, age. This is a method. Person 1 is an object. Person is a class. Alice as a name will be passed. Person 1. Self is reference to person 1. Name, Alice, age 30. Now if you call the function, see, person 1 is an object. So it can access all the properties of the class. Now if it access person 1 dot greet, that means this function, this method, to be more clear, this method will be executed. Okay. So this is all about classes, objects, attributes, and methods. Okay. In our next session, we will continue this. So till then, bye. Happy learning. Hey everyone, welcome back. In our last class, we understood about class, that is the blueprint, object, that is an instance of a class, attribute, that are the properties of a class, and methods. We also studied how we can access any attribute of a class in this way and how we can access any behavior or function of a class which is known as the method of a class. Okay. Now in our last class, we created this class called dog and we created an instance named my dog. We can create multiple instances also. Let's revise by creating one more instance. Your dog equals to class name, pass the parameter. Okay. Now if I try to access dog dot name, put it in print function. Okay. So we can create any number of instances. So you can see that each dog has separate instance with its own set of attributes and capable of performing same set of actions. Let me show you. Your dog dot sit, my dog dot sit. See, different dogs, different set of attributes can perform the same thing. So these are the advantages of using a class. Now create one more class like class car. Car will be the, now you tell me what is car? Car is the class, that is the blueprint. Put something inside the doc string, describe it. Now write a function. First, the special function, the special method, constructor, exactly, underscore, init, double underscore. What will be the first parameter? You tell me. Self. Self is the first parameter. Self is the reference to the instance. Now I give make, given model, and year. These are the attributes. So I have to first define the attributes. Self dot make equals to make. So whenever the object will be created, automatically these features will be allocated. Self dot model. There must be some model. Self dot year. The year on which it has been manufactured. Okay. Now write another method. Def get name. Self long name equals to formatted string. Self dot dot year. Self dot make. Self dot model. Okay. Now return long name dot title. Now create an object. My car equals to car rd to 2018. Okay. Now print my car dot get name. Title function will capitalize the first letter. Okay. Now let me run it. See. So we have implemented the car class and I have created an object called my car. Now let's understand how we can set any default value to any attribute. If I give self dot odometer reading equals to 0, create a function def read odometer print formatted string. This car has self dot odometer reading miles on it. Okay. Now let me call this function my car dot read odometer. Okay. Now let me run this. Uh, Sorry. Self is mandatory. Okay. So we have given a default attribute here. Okay. So by default, whenever I am calling this function, it is going here and taking the odometer reading 0 because we are not passing anything as odometer reading. Okay. So we can give any default attributes also. Okay. Now suppose if I write my car dot odometer reading equals to 23. Then what do you think? This will be an error or it will modify? See, it has been modified. So 0 was by default. If you provide nothing, it will be 0. But if you want, you can change as well. Okay. Here we have changed the attribute directly, but we can change it by using any method also. Let me show you. Here, if I write Def update odometer self mileage. Now self dot odometer reading equal to mileage. Now suppose I call uh, my car dot first I have to update the odometer. I will update by passing the mileage because it is taking one argument. So I can give here 27. Now if I try to call the read odometer, see what happens. It has been updated. Okay. So by calling the update parameter and passing the mileage, I am first calling this function. Mileage is set. So the attribute is updated. Okay. Now if I call the read odometer, so it will call this function and the car has odometer reading which is updated already and it will print. Okay. So you can change any attribute by using a method also or by using directly also. Okay. Now I will show you one more thing. Let me first write and you guess. Def increment odometer. Now self dot odometer reading plus equals to miles. Now I will call my car dot, sorry, I have to pass self always. My car dot read odometer. Before that I have to increment. I have to call the increment function. So my car dot increment odometer and increment odometer by have to pass an argument miles. So I pass 30. So I want the odometer to be updated with adding by adding 30 miles. Okay, now let me run this one. See 27 plus 30. So it is 57. So what are the things we have learned in this class? Creating multiple instances. Second, setting any default value for an attribute. Third, modifying any value directly. Fourth, modify any value using a method. Fifth, incrementing any value through a method. Okay. So from our next class, we will start the properties of OOPS. Okay. Till then, bye. Happy learning. Hey everyone. In this session, we will understand the concept encapsulation. Okay. First, I will do something practically. Then I will explain what the encapsulation is all about. Now first understand there are two types of variables. Number one is public. Number two is private. Here I have created a class. The name of the class is card. Inside the class there is a constructor taking two arguments, model, year. Self is the reference to the object and I have created the object my car. Okay. Now suppose if I want to access any attributes like mileage, so I can write my car dot mileage and suppose I want to print this. There is already a default value, so it will be printed as 0. 0 is the default value. Now suppose I want to update the value, I can do that. We have seen in our last class 10,000, make it 10,000 and then print it. So 10,000 will be printed. So this is a public variable. Anybody can access the public variable. Now the thing is that suppose the programmer who is creating the class does not want the user to see all the variables. Instead, he want to keep some variables private. Now, how can we do it? By giving an underscore to the variables. Here I have given a underscore in front of mileage. Now mileage is a private variable. Okay, now if I want to access my car dot mileage, now let me run this one. See what is the output? Car object has no attribute mileage. There is an attribute mileage, but it is shown to the user that car does not have because the developer has made it private by giving the underscore. So if you provide nothing, this becomes a public. If you provide underscore, this becomes a private. Okay, so user can see what is inside the class. Now if he knows that there is a private variable named mileage, he can access this by my car dot underscore mileage equals to 23,000. Okay, now let me show this one. Now suppose I want to print this. It will showing me as an error because I have written mileage. I have to access it by giving the underscore because it is a private variable. See. So you cannot access any private variable directly, but you can use by giving the underscore in front of the variable. Clear? Now the question is, what is the benefit of making it private? Just because this is a way of saying that this variable is private because I don't want you to change this variable. I want to keep it private. That's why I have kept it private. So you should not change it. But if you think you need to change, then you can change it. Simple is that. So it is not recommended that you change. But if you think that it's a must, you don't have other choice, then you can change. Okay, this is like a warning. This is like a caution. If you want, you can do, but it is recommended, it is advised that you should not do that. Simple. This is the logic of Python. Okay. Now Python says that don't change it directly, but change it using any method that will make it more secured so that nobody just can come and write one line of code and change it. If that person wants to change, it should be changed using a method. That's what I will show you right now. Now here I have created a class named car and I have made all the attributes as private. Now if an object is created, car, passing the arguments, and now if I want to print what is the make, what is the model, what is the year, what is the mileage, we have to access it using a method. So get make method will be called, see here this method will be called, which will return the make, which will return the model, which will return the year, which will return the mileage. So what is happening here? We are not directly accessing the attributes because these are private attributes. So I can't see what are the private attributes are over there. So I will call the function which will set the values and return us. That's what will be printed here. Clear? So what does the oops does here? It is encapsulating the attributes, the methods, and making it a secured thing. It's like a capsule. It is a secured way of keeping the medicine, encapsulating the thing. That's why this term is known as encapsulation. Oops also encapsulates by keeping the attributes, the public attributes, the private variables, and the objects together inside a capsule. Okay, so that anybody from outside cannot just access it directly or change it or harm it. It can just access it using any method. That is what is known as getter method. Now suppose if I want to change something, we also cannot change it directly. For that also we have to use a method. That's what is known as setter method. See here, I have updated the mileage. Here I have created a function add mileage which will take an argument. So now if you want to update the miles, you just cannot add it directly. Instead, you have to pass this to this add mileage function. See here, I have passed 100. So once you pass it, it will this one will be called 100 will be passed. Now if checks miles greater than 0, that is a condition that if it is greater than 0, then add it. See here what happens. The private attribute mileage is getting updated. So you understand the difference? I'm not just directly accessing it. I'm not directly printing. I'm not directly updating or I'm not directly retrieving the value. Instead, I am setting it through a method. I am getting it through a method. Okay. So that is what is known as getter methods and setter methods in OOPS. You have to set it first using a method. You have to update it using a method. You have to get it using a method. Okay. So this is what is encapsulation all about, which is the properties of object-oriented programming. Bye. Happy learning. Hello everyone. In this session we will study about inheritance. Inheritance simply means you inherit the properties of your father. So you have some of your own properties, your unique properties, plus you are inheriting the properties of your parents. Same concept applied here also. One class can inherit the properties of another class. Clear? Now let me show you the code. Here I have created a vehicle class which has a constructor, see, and one method display info. Now I have created another class which will be inheriting the properties of vehicle class. That means car will have all the properties written inside the vehicle class. That means if you create any object of car class, you can access this constructor, you can access this method or anything else. Clear? So here vehicle from which you are accessing the properties. This is known as parent class, like we inherit the properties from our parents. Same car, that is the child class. Who is inheriting is the child class. So you can see I have already created a vehicle class. Now inside the car class, simply I write nothing. I can give pass. Now how can we inherit the properties? Car can inherit the properties of vehicle by passing the class name as arguments. Clear? If you write in this way, car in bracket vehicle, that denotes that car is inheriting all the properties of vehicle class. Clear? Now let me create an object. My car equals to car. See here I have written nothing inside the car, but I have inherited the properties of vehicle. So I can access all the things inside the vehicle. Let me pass some arguments. Toyota. Now let me write Camry. Okay. My car dot display info. So it will call the display info function. Clear. So here vehicle is the parent class, car is the child class, car is inheriting all the properties of vehicle class. Now I will add something inside the car class also. Okay. See here I have written it. Here I have created a vehicle class, the same one, car, inheriting the properties of vehicle. Here I have created a constructor within a car class. Now the question is that if I create an object of a car class, which constructor will be executed? Of the car class or of the vehicle class? Because in both the class I have written a constructor. I have used this super method. That means it will first call the constructor of the car class. And now it will see that here it is written as super. That means you have to inherit these properties as well. So in the car class, you have the properties of constructor of vehicle class plus you have added something. Okay. So as of now, I can say within car class, I have self.make equals to make, self.model equals to model, self.color equals to color. Clear? So what is the benefit? That you do not need to repeat those things. You just write a simple keyword that is super and automatically everything will be inherited. If you have 10, 12, many attributes, you don't no need to write anything. Just write the super class. Automatically everything will be inherited in the constructor of the car class. Clear? Now I have also created a display info method. Same. So this method will also inherit all the properties of this class because I have used the super keyword plus I have added something. Okay. So I have inherited all the properties of my parents. Something I have also gained some properties. Clear? So now if I create an object like my car and I have to pass all the parameters total, make, model, color, all these three parameters because here I am passing make model to the parent class. So I have to pass all the three parameters. So how will it execute? Simply object will be created. My car is a reference of self, Toyota, make, Camry, model, blue, color. Again, it will go to the next line. Super.init. Super means it will see for its parent class. Parent is vehicle. So it will go for the constructor of the parent class. Here it will send the make and model. That means Toyota and Camry. So it will be passed make Toyota model Camry. Then self.make equals to make. That means For this reference, for my car, for my car, the make will be Toyota, the model will be Camry. Okay. Next line, in the next line, I am calling the display info method. Same, it will go here in this section. Now it will see that there is a super method. That means it is calling the parent class. That is the vehicle. Now it will go inside the vehicle class. It will say there is also a display info method. It will pass the object. That is the my car object. Now it will print these things. Once it is printed, it will again come back to the calling code to this line super.display info. Now the next line will be executed. That is self.color. Color was set here in this line. Color is blue, so blue will be printed. Clear? Let me run this for you. Okay. Simply, it's just inheriting all the properties. So this is the inheritance property of O. Now inheritance is of four types. Here we have understood the single inheritance. That means you are just inheriting the properties of your father. Clear? This is known as single inheritance. Let me draw it for you. Here, this is your father. You are inheriting all the properties of your father and like this. So there is a single inheritance. Now there are other types of inheritance like multiple inheritance, multi-level inheritance, hierarchical inheritance. What is multiple inheritance? Multiple inheritance means you have your mother also. So you just inherit the properties of your mother also, not from your father only. You are getting from her also. That is what is known as multiple inheritance. Clear? What is multi-level then? Multi-level means you are inheriting from your father. Okay, fine. That is single level. But your father is also inheriting from his father. That is your grandfather. So there is an inheritance of different levels. That is what is known as multi-level inheritance. Clear? Your father is inheriting from his father, your grandfather. You are inheriting from your father. So there is more than one level, what is known as multi-level inheritance. Okay. The next one is hierarchical inheritance. Hierarchical inheritance means it's like your father's property is inherited by you, by your sister, or by your brother. Okay. So your father's property, but inherited by you, by your brother. This is known as hierarchical inheritance. Okay, first let me show you what is multiple inheritance. Multiple inheritance means I said you are inheriting from your father, from your mother. That means you have two parent class and one child class. Clear? This is a parent class. Okay, two parent class. One is vehicle, second one is electric device. For vehicle, we have a constructor, we have a method. For electric device, we have a constructor. See, only the battery capacity I am taking as an argument and I have a display battery capacity method. Okay. Now I want to create a child class which will have the properties of vehicle and electric device. That means it will be vehicle and this is electric device. These are both of them are parent class. And what is the child class? That is electric car. This is the electric car. Clear? So now how can we do it? By writing electric car and pass both of the classes vehicle electric device because you are inheriting the properties of vehicle class, you are inheriting the properties of electric device class. Okay, now inside the class I have created its own constructor and I am passing all the necessary arguments. Okay, now first I have to inherit the constructor of vehicle class, so I have written vehicle.init self make model. I also have to inherit the properties of electric device class. So I have written electric device dot init self battery capacity. So inheriting the properties of electric device. Okay. So now in the constructor of electric car, I have also inherited the constructor of vehicle class, the constructor of electric device class. And I have created a display info method. Here also I have a display info method. So I am inheriting this method by giving the super keyword, and display battery capacity. This is a new method. So I am inheriting this by writing in this way, self.display battery capacity. Okay. So I have inherited everything from vehicle class and from electric device class. I have also added some of my own, that is color, self.color. Here I have initialized and now I am printing. Clear? So now my electric car, that is the object, electric car, that is the class name, and I am passing all the necessary arguments. Okay. First, the object is created. Init will be executed automatically. All the elements will be passed over here. Next line, vehicle.init. That means it will go here. Make, model. All this will be set here. Now it will come back. Next line, electric device.init. That means it will go here. Battery capacity will be set and it will come back. Next, color will be set here. Clear? After that, when you call the next line, that is my electric car.display info, it will go into this one here. Next, super.display info. That means it will go to the parent class, display info class. Here it will be printed. It will now come back here again. So next line, self.display battery capacity. So it will find the display battery capacity method of the electric device class. Now it will go here. It will print this. Again it will come back. Next it will print self.color. So you get the point how it is executing. Let me show it to you in Python tutor. First, vehicle class is created. Init constructor display method is the method. Next, electric device class, same constructor, its method. Next, electric car class, which extend vehicle and electric device. It has its constructor and its method. Next, init will be executed because I have created an object, that is my electric car. So this constructor will be automatically executed. Now self is pointing, that is an electric car instance, that is an object. Make is Tesla. I have passed all these values, model, color, battery capacity. Okay. Now it will go to the next line, that is vehicle.init. So it will go to this constructor. See, it is pointing to this constructor. Now make will be set, model will be set. See, it is set over here. Next, it will again come back to this line. See here the red line, electric device.init. So it will go to this init of electric device here. Now next line, self.battery capacity. So battery capacity will be set. See here, battery capacity is set. Now it will again come back here. Self.color will be set. So you can see color is set but return value is none. Next line, it will go to the next line, that is display info. So display info method will be called. So it will go here in the display method. Now it will go to the next line. Next line means super.display info. That means it is calling the display info function of its parent class. This is the parent class. So display info will be executed. This will be printed. Let me show you. Here it will be printed. See, this is printed. Now again it will come back to this line because super function has executed. So it will come back to 25th line. Now it will call the display battery capacity method. So it will go to the 14th line. Clear? Here it will be printed. See, it will be printed. Battery capacity 100 kWh. Okay. Now again it will come back. Color will be printed. Color will be printed. Clear? So now it is done. So this way you can also visualize the things. You can see how it is actually working. Concept is simple. You are just inheriting so that you don't need to start from the scratch. Practical example, you can consider that you have an iPhone. iPhone 15 must not start from the scratch. Instead, it will inherit all the properties of iPhone 14 and it will add some of its own. Clear? Any model, any kind of version, any version of a new book, any version of a new car, what happens? They don't start from the scratch. They have all the features they had till their last version, and they are adding something of its own. Okay, so that you don't need to start from the scratch. Now the next one is multi-level. Multi-level inheritance. This one I said you are inheriting from someone. That person is inheriting from someone. Okay. So here vehicle superclass, car intermediate subclass, sedan as subclass. Let me copy paste first. Vehicle is the superclass. This is the vehicle. That means this is the grandfather. Now car is the intermediate subclass. Where is car? Here car is inheriting all the properties of vehicle, and then sedan as subclass. That means sedan is inheriting all the properties of car. See, vehicle is the parent class. Car is inheriting the properties of vehicle. So car is the father, vehicle is the grandfather. And now sedan is inheriting all the properties of car. Sedan is the child, sedan is you. Clear? So this inheritance is done in multiple levels. That is why it is known as multi-level inheritance. It is also simple. Just here I have created a constructor which is inheriting super dot init means it is inheriting the init of car. Car is inheriting the init of vehicle. So sedan has all the properties of car or vehicle. Next, it has added something of its own. Clear? It has its own method display info, which is inheriting the method of car super dot display. Car is inheriting the method of vehicle. Clear? And it is creating some of its own also. So my sedan is the object. Whenever the object is created, it will go to the init. It will pass Honda make, model Accord, color black, number of doors 4. Next line, it will call the super.init function. That means this one will be called. Here, make model color. This will be set here. Now it will call super.init. So automatically it will call this function. Here, make and model will be finally set. Okay. Now next, it will come back and myCDN.displayInfo is called. When it is called, it will go to this function. Again, there is a super. That means it will try to find its parent. So it will go here. Here again super. That means car wants his parents. So it will go display info. This line will be executed. It will come back to the calling code. This line will be executed. It will come back to the calling code. Then this line will be executed. Okay. So if you run it, you can see the output. Okay. You do it using Python tutor if you have doubt, but I don't think you should have any doubts. Okay. Now another is hierarchical inheritance. Here I have created vehicle as superclass, car and truck as subclass. Car is you, truck is your sister or your brother. Vehicle is your father. Okay. Now let me show it to you first. Vehicle as the superclass. So this one is going to be the parent, your father, vehicle. Next, car and truck as subclass. Okay. So car is inheriting the properties of vehicle. Truck is also inheriting the properties of vehicle. Okay, so it's like this one is the vehicle, car is inheriting the properties of vehicle, truck is also inheriting the properties of vehicle. Okay, this is known as hierarchical inheritance. Let me show it to you here. Class vehicle, it has its constructor class, display info method. Car is inheriting the properties of vehicle by super keyword, display info method. Truck is also inheriting vehicle. It also has its init class and display info method. Okay. So if I create an object of my truck, a constructor of truck will be executed. That means this one will be executed. So in the second line, it will try to find its parent class. Parent is vehicle. So it will go here. Make model will be set. It will again come back here. Color will be set. Payload capacity will be set. Okay. Next line, display info function is called. That means this method will be called. Try to call it method always. It is waste if you always call it as a method, not function. Sorry for my mistake. Now this is display info method will be called. So display method is called. Now super dot display info method, that means it will try to find its parent class. Parent is vehicle. So this one, now this one will be executed. It will come back to the next line. So what will happen? If color will be set and payload capacity will be printed. Color will be printed, payload capacity will be printed. Clear? Same things happen for car also. Car object is created, so init will be executed. It will try to find its vehicle class. Next, its color will be set. It will come back. Display info method will be called, and the same thing will happen. So this is what all about inheritance. In simple word, you are inheriting the properties, and the way you are inheriting the properties are the types of inheritance. I hope there is no confusion. You just take a program, run it in Python tutor, everything will be clear. Okay, bye, happy learning. Hey everyone, welcome back to this channel. In today's class, we will study about polymorphism. Poly means many, morph means form. That means it has many forms. Just we human beings behave differently in different places. Simply, a method also behaves differently depending on the requirements. Same method, but the output is different. Okay, let's see it. First, it is of three types. Number one, method overloading, method overriding, operator overloading. Now, method overloading is not supported in Python, but we will see what is that. And method overriding we have already understood in our last class while studying inheritance. Okay, first see, I have created a vehicle class, simple, a constructor and a method named display. I have created a separate class, car, which is inheriting the properties of vehicle, inheritance concept. So you can see that init is already inherited. I have not written anything else in the car class. And I have created a method named display in vehicle class, same name in car class. But both of them are working different. It is printing the model, but it is just printing something else. Okay. Now suppose I have created an object that is car, which is the reference to self, and I am passing Camry as the model. Now tell me if I call the display function, which one will be executed? This one will be the output, or this one will be the output? What do you think? Let me show you. See, the method of the child class gets the preference. Okay. So you can understand that if you write same method in child class as well as in parent class, then child class will get the preference. That means here the display method is overriding the display method of vehicle. This concept is known as method overriding. Clear? Now suppose if I write super dot display, then what do you think? Sorry. Then what do you think the output will be? Then first it will inherit all the properties of the display method of vehicle class. So this one will be printed first. That's why Camry is printed. Then it will come back and the next line will be executed. So here it has both of the properties, its own as well as it inheriting the properties of its parent class. But if I don't give this one, then it will simply override the parent class. It will just ignore the same method of the parent class. So the method of the child class gets the preference over the method of the parent class. Clear? Simply this is known as method overriding, which we have already seen in our last class, and I hope now the concept is clear. The next one is method overloading. Here I will create a calculator class. So I write def add function self a comma b. Now write return a plus b. Now write another function def add, pass three arguments a comma b comma c, and return a plus b plus c. A plus b plus c. Okay. Now suppose if I create an object of calculator class and then I call the object and I call the add function passing two arguments 2 comma 3. Okay. Okay. Now write print. Same one, I create one more object equal to calculator, and now I write print calc dot add 2 comma 3 comma 4. Now let me run this one. See, calculator dot add missing one required positional argument C. That means it is asking for one more argument. That means it is always going for the latest one. Suppose if I write one more method with the same name, self A, comma B, comma C, comma D, and I'm just trying to print return A plus B plus C plus D. Now see the change. See, it is asking for two positional requirement C and D. That means it will always go for the latest one. Okay, this is what is known as method overloading. That means you are creating methods with same name, just there is a difference in passing the arguments. This is what is not supported directly by Python, but you can do it in applying in different logic. Let me show you. Suppose if I write a b c equals to 0, then I write if c equals to 0, then return a plus b. Else c is not 0, that means there are more than two arguments, so it will be a plus b plus c. Clear? Now let me delete this one. Now if I run it, you can see the output. So 2 plus 3, 5, 2 plus 3 plus 4, 9. So you cannot achieve it directly, but if you want, you can do it by using other types of logic. Like here, I have used the default arguments. We started this concept that if you pass nothing, then C will become 0. If you pass something, then it will be overlap. Okay. So this concept is known as method overloading, where you can create methods with same name inside a class, but it is not possible in Python. Now the next one is operator overloading. That is a simple concept. Suppose I write 4 plus 5. You can tell me what is the output. Now suppose I write I love plus 4. Then what will be the output? Clear? Now suppose if I write 1, 2, 3, 4. I write 5 comma 6, then what do you think the output will be? It will be concatenated. Okay, so same operator, class operator, but performing different kind of operations depending on the requirements. So that is why this is known as polymorphism. So as of now, we have studied what is polymorphism, types, method overloading, method overriding, operator overloading. Python does not support method overloading. Method overriding we have already studied. The last one is operator overloading. Okay, bye. Happy learning. Hello everyone. In this session, we will understand the last topic of object-oriented programming, that is abstraction. Now let me give you an example. Suppose your parent wants to give all its properties to you, but he gives you a condition. Okay, you can take all my properties, but you have to bring 90% marks. So you get the point. You will get all the properties of your parents, but you have to fulfill the condition. That is what is known as abstraction. Here also, you have a parent class, you have a child class. Now, parent class says that, okay, you can take all my properties, but you have to fulfill some condition. So, the parent class provides some restriction to the child class. Now, let's see how we implement this. See here, shape is the parent class. It has its constructor and it has given as an abstract method. So this class is known as abstract class. What is an abstract class? Abstract class means it will contain at least one abstract method. Here you can see this is an abstract method. Now what is an abstract method? Abstract method is that condition which the child class has to fulfill. So here before area method I have written abstract method. That means if you want to inherit the shape class, then you have to implement this area method. You get my point? It's simple. Like rectangle. Rectangle is the child class. Now rectangle wants to inherit the shape class. So what does rectangle have to do now? It has to implement a method, that is an area method. This is must. If you don't implement the area method, you cannot inherit the properties of shape. Clear? Now see here, rectangle. Here, see, I have implemented the area method. You can write anything inside it, but you have to implement the method. This method must be present in your class. See here, the circle class, I am inheriting the shape function. You have to implement the area method. Okay. When a parent class declares any method as abstract method, you have to simply inherit this. And this, I think you have known in our last class, we studied that this is nothing but a decorator. So to apply this decorator, you have to import this ABC module. ABC means abstract base classes, where this abstract method is defined. So now to use this, you have to import this abstract method. Okay. So this is known as abstraction. This shape class is abstract class. This shape class is holding an abstract method. Area is that abstract method. Whoever wants to inherit the properties of shape has to implement this area method. This is the gist of everything. Okay. If you don't want to actually implement, then also you can keep it as abstract method and just writing it as pass. Let me show you. If I just write it abstract method and I write nothing inside it, then also it will be fine. Let me show you the output. See here, this one is executed. Uh, this one is also fine. I have not written anything, but I have just written pass. That means do nothing. And I have also mentioned that it is an abstract method. Okay. At least you have to keep this method inside the class. Here also, here I have implemented the area. Now if I run it, see, I have created two objects, rectangle object, circle object of different classes, and I am trying to print the area. So rectangle area, as I have written nothing inside it, so it is showing as none, and circle area, it is showing as 50.20. So clear, this is all about abstraction. We have completed everything related to object-oriented programming. Okay, bye, happy learning.